Hi everybody, this is the continuation of page 29. This is going to be just a very brief video about notation. So in the example at the top of this page, we kind of introduced the concept of finding rates of change of multivariable functions. Okay, and in the first box that you see here, basically just reminds us that rates of change are about finding limits. You might have recall learning this in Calculus 1, that the slope of the tangent line is really a limit. Okay, and that's all that's going on here. Most important point, I think, at the bottom of this page is talking about alternate notation for partial derivatives. There are several different ways that you can express partial derivatives, and depending on the situation, one piece of notation might be more useful than the other. Okay, so let's assume that we've got a function z equals f of xy, so a function of two input variables. We already talked about how we can use the notation partial z partial x to describe the rate of change of z in the x direction. Another way that we can write that down is like this. Fx of, not AB, x and y. We would read that the partial derivative of f with respect to x at xy. So these two notations mean the same thing. They're just different ways of writing the same, expressing the same concept. Okay, and then partial z partial y, same thing. We could rewrite that as just fy of xy. Okay, both of those are just ways of representing the rate of change in the y direction. Okay, and then if we want to talk about the derivative at a specific point AB, we could either write that like this, partial z partial x evaluated at AB, or fx evaluated at AB. Those two notations mean the same thing. All right, and then same deal over here. So we'll substitute the point AB into partial z partial y, and we could also write that as fy of AB.